So my name is Grace Denyer. I'm an innovation engineer at SP Energy Networks. So just a bit of background on who we are. We operate in both Scotland, England and Wales across distribution and transmission network, across a mix of both very rural and some major cities, as you can see highlighted on the map here. We serve both Glasgow and Liverpool. Just some background information on where this problem statement has come from. This has come from one of our jointers on the LV network, who's now moved into a lead engineering role, heading up our network controllable points and our low voltage monitors as well. So this is someone with a wealth of experience on many of the ways that network digitalization has advanced over the past few years. Again, that role most likely wouldn't have existed a decade ago, so it's amazing how far we've come. Even though the number of LV interruptions is trending down over recent years, there are still 15,000 LV faults across SPM and SPD, two of our license areas, in 2025. Even excluding service faults, which only interrupt one person, this is over 100,000 customers who were interrupted in 2025. So, as I mentioned, we do have a lot more digitalization on the network, a lot more information to work with. We have both LV monitors and recloser devices, which can give us an approximate distance to fault. However, this isn't precise. What we're asking for now is a way to kind of bridge the gap to say, we know where this fault is approximately, now how do we pinpoint that and get an exact location as fast as possible? Is it possible that there's a better method in light of all the other information that we have on the network? Where the rationale for this has come from is HV faults can be precisely located using a surge generator. This produces a surge of voltage down the cable after it has been isolated, causing wherever the fault is to arc. One engineer monitors at the substation and issues this voltage surge, while the other uses a specialized receiver device to go down, picking up on both the electromagnetic pulse from the substation and listening for that arc, which produces quite a loud sound. This isn't possible on the LV network currently, due to the fact that we can't isolate these cables completely. They will always be connected to customers, customer fuses and customer circuit boxes, which we of course don't want to overload anytime someone goes off. We'd also, on backfed cables, not want to isolate while we're fault finding. Turning off more customers than necessary is something we want to avoid. What we do have currently, impedance traces, give us an approximate area. However, the vast majority of low voltage underground networks have multiple paths that this fault current could take. So just a distance in meters doesn't necessarily help us, although it does narrow things down. This is especially prominent in mesh networks or networks with multiple branches or with a lot of service cables. This is compounded by imprecise network plans, things like the wrong cable type being monitored or imprecise cable lengths. So our current method is to use a sniffer device. This is a fantastic tool. However, this requires drilling into the ground and it isn't always the most reliable, particularly when there's a lot of ducting or when there are these imprecise cable plans. If you're detecting for gases permeated into the soil and you're on the wrong side of the road, it's a struggle to find if you're just missing the fault or if you need to relocate the cable because the plans are so outdated. So any imprecise fault location that we treat as positive results in more excavation, more cost, and more time for the customers in which they need to be reinstated. This can contribute to a poor customer experience. It's more time for our engineers on site, and overall it's a high cost to the DNO. So what are our expectations? We're looking for a portable unit that can quickly and precisely locate low-voltage underground faults. I've spoken a bit about surge generation. While we believe that that's one idea that could work very well, if possible, we're very open to other ideas. There have been some interesting papers about electromagnetic detection with smaller pulses sent through that don't necessarily need to trigger that arcing current, but can still be detected. This should be capable of connecting to a low-voltage fuse board within a substation, and potentially a link box as well, just any point on the network that it can connect to. So we have a few options here. This is repeated in the problem statement. Yeah, this could look like a portable surge generator, controllable enough that it will not cause any damage to customer property. This could either be connected to a LV board, a link box, or just one or the other. But we are also very interested in any solution that allows quick location of these faults after an impedance trace has been run without the need to use a sniffer. All right. So the key issue here is any solution we would want to have the ability to let us know. Within the solution, we'd want a period of research to let us know how is this going to impact our customers? Is this safe for use on the network? So even if we have a solution with a very high TRL, we'd want potentially an innovation project or potentially as BAU, the innovator to work with our design and standards team to let us know what could the potential impact is on customers and the use cases for this. So yeah, any disturbance to customers should be limited. We're hoping any solution will have settings for the various different types of low voltage network. So a radial network can withstand much less fault current than an interconnected network, and very short radial feeders will not need as much power. Any solution should comply with things like ESQR, British standards and international standards. And we'd want some danger signage and some safeguarding against, in the case that someone's been digging and they've accidentally struck one of those underground cables, we would want this device to be able to be remotely deactivated if the jointer walking the line finds this is an unsafe situation, or we'd want a built-in safeguards in case this detects that it's exposed to open air. So this is just some pictures of what I mentioned, an LV link box on the left and an LV fuse board on the right. So these are just fairly simple metal connections, but what's key to bear in mind is we would want this not to be able to slip once it's applied, so locking mechanism would be ideal. So we're looking for plans rather than just ideas of solutions. We're interested in any TRL readiness of technology. And then that's my key contact there. And the second person down is John Windram, who is our subject matter expert on the low voltage network. Thank you. Did anyone have any questions? Or, sorry. Thank you.
Okay, you'll do a quick look around for any questions in the room.
What does portable mean?
So portable here would mean we wouldn't want this device to be left in a substation. Anything small enough to fit in a van or small enough to fit in a kind of a large-sized car boot would be ideal. And then typically these devices, if you were to go with a surge generator, have a receiver. This needs to be able to be taken by an engineer and walked down the length of a cable while they're listening for that thump. So this, of course, operational health and safety should be as lightweight as possible. Did that answer your question?
Yeah, but how do you expect to have data into that portable device from the substation? So obviously to monitor those cables, you need voltage, current, waveform, frequency, and all the rest of it.
So we already have tools within our substations. We have a rollout of LV monitors aiming for, I think, 85% saturation soon. So it's safe to assume that when the LV engineer goes out onto site, they'll be able to go onto our data portal, see, okay, here are where we think that this fault is located and start from there. But if they would have issues in finding that, we'd want this device to be able to find a more precise location requiring access on-site and testing on-site.
So, so once the fault location is identified, then they can do that. But how do you expect the portable device to identify the location? How do you transfer data from the substation, from the monitoring device onto the portable device in the van?
We're anticipating either a third-party data software. We have our own data hub where all data from our LV monitors is kept. This also takes data from recloser devices, which do a similar function in terms of impedance tracing. So the LV engineer would go to site, look at this, and we wouldn't necessarily want to collect data from this fault-finding device. We'd assume someone's there physically on site, just looking for a precise fault location that would then be marked on our plans once it had been found and excavated.
Thank you.
Thank you.
Any more questions in the room?
Excellent. Hi, Paul Holmes, Fundamentals. Does it have to be a device that is actually taken to the field, or could it all be done by monitoring and we give you a map reference and tell you where it is?
Something we're very interested in is, now that we have all this data, are we using it to its fullest capability? If you think that this data could be used to give us a more precise fault location without even the need for a device on site, that's ideal, and we'd be very interested in hearing that. But we've run through some of the issues there are our branching paths. This isn't as much of an issue on radial networks as there are less routes, but in mesh networks, we have some, especially in Liverpool, that get very, very complicated very quickly. So just a distance to faults, while it helps in terms of narrowing things down, it doesn't give a single precise location. But if you believe that there is a way to narrow this down to find a most anticipated solution, we'd be very, very interested in hearing about that. Yeah. Thank you.
Well, thank you. I think we have just one question for you on Slido as well, Grace. So what are the most anticipated use cases for the device?
So we're not anticipating that this would replace sniffing devices, but we're anticipating this would be best used in those kind of interconnected mesh networks where we have a lot of potential fault locations. We know that maybe our data is bad, or that we have a lot of cable ducting that might prevent a sniffer device from being as effective as it can be in other networks. So yeah, generally built up urban areas are our kind of key use case for this device.
Wonderful, thank you. Quickly open for any final questions? In that case, thank you so much, Grace, for your presentation. And thank you all who are still in the room with us. I think you're the most innovative minds, in fact, in the building, because you have delayed your lunch by 20 minutes. But we do hope you enjoy lunch.